So how do we figure out whether or not I'm going to have a 0 in the bottom before I start doing the problem? There's this thing that's called sneak a peek. Plug in the x value of the limit into the function. If you see some number, let's say a over b, and they are non-zero, everything will be okay, and you'll be able to use the limit laws. If you plug in the number and you see a 0 over 0, this is no good. You cannot use the limit laws because there's a 0 in the denominator. You're going to have to use algebra to rewrite the limit and get rid of the 0 from the bottom. If you ever see some number over 0, you cannot use the limit laws either. This is where we do something called an analysis to figure out what the limit is doing. In this case, you're going to have an infinite limit. So it's going to be very much like we talked about in chapter 2.2 with vertical asymptotes. So I'm just going to focus on this 0 over 0 case. This is the case that we are going to see a whole lot in this part of the course. And so a very typical kind of example is something like this. Let's say the limit as h goes to 0 of square root 1 plus h subtract 1 over h. Can I use the limit laws? And so the idea is that I'm going to sneak a peek. I'm going to just mentally let h equal 0. Now, this is not part of my solution. It's just a way for me to see what's happening so I know how to go next. You should see that I end up with a 0 over 0. So everywhere I see a letter h, I'm going to replace it with a 0. And as soon as I see a 0 over 0 like that, this is the math's way of yelling at me, no limit laws. I have to rewrite this thing with algebra to get rid of the 0 over 0. And so how am I going to do that? So this is the part that depends on the problem. 1 plus h subtract 1 divided by h. I have to use the rules of algebra to make this expression look different, but not change its value. Whenever you've got a square root plus or minus a number, there's a way to rewrite it to move the roots around. Algebra says I'm allowed to multiply this thing by 1 and it won't change its value. But I don't want to pick a silly form of 1. I would like to pick a form of 1 that's useful for me. And so I'm going to choose this thing. It's called the conjugate. And the reason that I do that is because it's got this wonderful property. Upstairs, it's going to get rid of the square root when these two things multiply each other. So I multiply the first two terms and I get a 1 plus h. Then I'll get this junk with the square root when I multiply it there. I get a same term with the square root, but with a negative sign, and then subtract 1. Now downstairs, I'm going to get a big mess that I'm just going to leave alone, and I don't care what it looks like. Those two ugly bits with the square root have vanished. It allows me to rewrite this thing as an expression that has no square root in the top, but is equivalent to what I started with. These ones will cancel out. And what I'm left with is now an expression that looks like this. And what you're trying to find is that 0 over 0 that was giving you a headache. And by doing all of this algebra, I found it. There's this factor of h over h. That's effectively just a 1. Or students like to say, oh, you can cancel that. Now I have this expression. Now I think I've gone as far as I can go. Is that 0 over 0 still there? So if I let h equal to 0 in this expression, just on the side, in my head kind of thing, I'll see a 1 upstairs and I'll see a 2 downstairs. And so that means I'm going to be able to use the limit laws. I'm just going to use them all in one shot here. And yes, you can use them all in one shot like this as well. With time, you will get really comfortable with using the limit laws. So when I go through and I practice using the limit laws and I work my way through, this is what I end up with. And I know that the limit as h goes to 0 of h is 0. And I know that the limit as h goes to 0 of a constant is a constant. And I know that these exist. Everything I'm doing is trying to rewrite back in terms of those basic pieces, and I've got it. Now I just evaluate all those limits. I plug in their values, and guess what I get? A 1 over 2. And this is the procedure. My advice to students is that when you're faced with a strange limit, the first thing you do is sneak a peek, and you listen to what it's telling you. If you get a 0 over 0, that means there's a 0 in the bottom, there's going to be problems. You cannot use the limit laws right away. You have to do some algebra. Here we used conjugates. But it could be anything you've learned in a pre-calc class. So it could be, common denominators, expanding things, factoring things. It all just depends on the expression you've got.